It's getting slower and slower nowadays. Right. Uh, let's begin. So visual. So it lags a lot. I think it lags a lot. Right. Let us save this. Just going to write C program tutorial. Okay. C program tutorial. And we can run this, right? Anyways, let us begin with the first language. Let's just, write. So explain entirety of chapter 1. Can you do that? So can you explain entirety of chapter 1? Slow down, slowly, step by step. Let me understand what's going on. Is going on. All right, I think we're a little faster now, but still. All right. So what is actually happening? So if I were to write this code, oh, we can't write it. Okay, what's going on? What is the error? Isn't it stdio.h? Yeah. So I'm just wondering, like, what's the error here? Okay, quick fix. Um, sure. Let's create a C++ file. I marked done. Cool. So now we start a new file. Okay, still can we still run? No. Um, okay, fix it. Damn, Visual Studio Code has this. I didn't know that. What do I do? I am confused. Nice. Actually fixed it. So cool. Oh, come on. Okay, so let's just go on. So obviously, what is happening in C? So if you were to write what's include stdio, so what happens is that compiler will convert into the machine code. The machine code will become binary instructions. CPU will then execute these instructions, and then the screen will display hello world. So C is called a low-level language because it's very close to hardware, meaning you can control the memory, you can control you can store like as registers. You can have hardware pins, timing, sensors, motors, like everything. So C is more of like a low-level language. Embedded C, what's embedded C? The normal C runs on computers, like normal computers, like the computer that I'm using. The embedded ones runs on microcontrollers or microprocessors, like drones or rockets or machines, washing machines, anything that needs, you know, any sending or transferring of devices, transferring of information. So even probably maybe this computer also has. Oh, is there anything I need to keep? I keep getting this error. I don't know what this error is. I'm not sure, but I keep getting this error. I keep getting this error. I'm not sure what this error is. Sure what this error is. Yeah, I know it doesn't have a compiler. Okay, I know obviously. Controller plus control plus. Okay, what did I do? Yeah, no. I can't do control plus because it automatically zooms in. Okay, open terminal in VS Code. Okay, I just open terminal here. And if I write GCC version, oh no, it should be version. Oh, come on. Nah, it's not going to work. It's not going to work. GCC version. Okay, so GCC is not recognized. So the term GCC is not recognized. What is going on? Okay, I don't know what's going on. But GCC is not recognized. Yeah, I know. I know. It's a GNU compiler collection, but okay, min GW W64 download. Okay. So this I have to. Yeah, I'm using Prism Lens. There. All right. I think we're good now. Windows. Windows. Where's Windows? I just saw Windows. Windows. And how do I install it? Right. Uh, I am really confused. What do I do? What do I click? So then install. I don't see it though. MSYS2. Okay, I don't see MSYS2. Okay, MSYS2. Then what do I write? I don't see an installer here. Oh, there. Okay, which one do I click? So now you'll see carefully. So you see UCRT64. UCRT64. Don't tell me why should I install UCRT64, but not yet. So there is 3,736 packages. Which one? Yeah, I mean, this popped up. So apparently this popped up. Do you have an option to select all? Yeah, no. There's quite a lot. Ooh. Okay, wait, stop. One by one. I opened and I clicked on it. It shows me 3,736 packages. Yeah, but I don't see it though. Yeah, I don't see it. That's the thing. I don't see it. Yeah, I don't see it. That's the thing. Because um also do I click on this? Oh, okay, there you go. But I swear it is so slow, man. All right, by then, let's just look at this um program and whatever. So we know what a bit is. There, 1 bit, and then character is 8 bits, unsigned integer, unsigned character 8 bits, signed character 8 bits. So unsigned is usually 0 to 255 because unsigned usually only has positive, and positive you don't write +0 or +1. You don't write that. But a signed integer you have 1 minus 128 to 127 because it's a signed integer. So obviously you can have a minus in it, and then integer obviously it's 16 bits. So it's going to be 2 to the minus 2 to the power 16 to 2 to the power 16. Okay, yeah, next. So 2 to the power 16 to minus 2 to the power 16 and vice versa. And then short integer, they're the same thing. Unsigned integer would be, so minus 2 to the power 16 plus 2 to the power 16 is 0. And on the right hand side, you're going to have 2 to the power 16 plus 2 to the power 16, which is 2 to the power 32. Whatever the value for 2 to the power 32 is, whatever the value for 2 to the power 16, so 2 to the minus 2 to the power 16 plus 2 to the power 16 is, which is 0. Right? Long integer is a 32-bit because you're going to have 2 to the power 2 to the power. Wait, 1 minute. What is no 2 to the power 16 plus 2 to the power 16 is not 2 to the power 32. 2 to the power 16 plus 2 to the power 16 is whatever the value for 2 to the power 16 plus 2 to the, so it's 2 times 2 to the power 16. This is 2 to the power 32. So 2 to the power minus 32 to 2 to the power 32. And this is minus 2 to the power 32 plus 2 to the power 32 to 2 to the power 32 plus 2 to the power 32. And then also signed integer is the same thing. So signed integer, so anything that's signed is going to be minus 2 to the power whatever the bit number is to 2 to the power whatever the bit number is. And if it's an unsigned, you're going to have minus 2 to the power whatever the bit number is plus 2 to the power whatever the bit number is. And on the right hand side, you're going to have 2 to the power whatever the bit number is plus 2 to the power whatever the bit number is. Is this installed? Okay. So the variable scope, as noted above, constant and variables must be declared prior to their use. So the scope of, when you do the code, right? So like here, you're gonna write int value is equal to 1. So something like that. You're gonna write int value is equal to 1. Or if I want to write character name Sarkar, or if I want to write um, Sorry. That should be, yeah. And then if I write string um, full name, who the fuck is Tazaz Hussain? The fuck? Tada, man. Right? So something like that. So character only works. Actually, yeah. So in most cases, character usually works. So actually, character works in both the full name and the the letter. But if we have a letter, so character, let's say first word, you should have one caps lock. One caps lock. Oh, come on. Oh yeah, and also this. So when you have no, 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 it should be okay. I don't know why is it double quotation, but it should be one quotation, because in some compilers they use one quotation. Like here, I don't know, they use two quotations, but in general you're gonna have one quotation if you're using a character, and you're gonna use double quotation if you're using a string for both, like a string, like a full name or the name of the person, something like that. And then you have double, um, 3.14. So double pi, that's 3.14. And if you write float pi, you know, 3.14, 3.14159267, whatever, right? And when you print it, when you write dot to f, so if you write, if I'm just going to put a hashtag here, if you write dot to f, means two digits. And if I write dot f, dot f, this means there's not going to be any digits, like none. So it's like kind of like an integer value. But if I just, let's say, write printf pi, pi, it's going to print all of it, right? Unless and until you put a restriction. Double, even if you write double, double pi, 3.14159266, whatever, and if you print it, no, it's not going to print 3.14159. It's going to print 3.14 because it's a double. Double can only support until two decimal points. Right? Is it done? Okay, finished. Now, I installed it. So I installed it. Okay, so I'm in a terminal now. I'm in this terminal here. This terminal here. Come on, come on, come on. Very slow, very slow. So type this exact command. Right, Pac-Man 5. I'm just going to write exactly what he said. Okay, I have to write it down. Pac-Man 5 min GW W64 CRTX86 64 GCC. Okay. Oh, it's Pac-Man S min GW W64 CRT x86 64 GCC. Yes. All right. I think we installed everything. So everything is installed. Now, let's go here. GCC version. Oh, come on. GCC version. Okay. Um, fatal error. Okay, there's a fatal error. GCC version. The GCC version. Okay, it shows 15.2.0, which is working. It does show. Yes. It. Now can I run? Okay. It does show. Yes. All right. Come on. Come on. Come on. All right. Yeah, yeah, yeah. Okay. Save your file. So I'm going to save as the program tutorial. And I still get the same error. Okay. GCC. Okay, okay. It'll be GCC. Wait, what? GCC. Oh, God. GCC. The program tutorial dot co main. Okay, now it says fatal error. Do I have to restart? I don't mind restarting again. And let's see if I write include stdio.h int main. Oh god, what happened? What happened? What happened? What happened? And let's save this as main. Oh, so it still doesn't work. I did that. It still shows fatal error. I don't know why does it say fatal error. Oh my god, my back hurts. So it says fatal error. Alright, you know what? I'm just going to